end is near for fossil fuels, and the energy sector is looking for the best replacement for them. It's been a challenge to find an energy generation method that can replace oil, gas, and coal without having too much of a downside themselves. Today, we're going to be looking at one method that looks pretty promising to us and might actually be the real future of energy: the hydrogen fuel cell, using hydrogen to make energy. The term hydrogen fuel cell sounds new and fancy, but it's actually based on technologies and materials that have been used in different industries since forever. In general, a hydrogen fuel cell would consist of a way to introduce hydrogen and oxygen into the cell. The two gases then react to form good old H2O, and the electrons that are ejected from the process are caught in something called an electrolyte. Through the connections the electrolyte has to a circuit, these electrons can then join a current and power whatever needs to be powered, also called the load. If there's a steady supply of hydrogen and oxygen, you could keep this process going forever, just like a steam turbine. There are many types of hydrogen fuel cells. Some are being used for applications already, while others are still ideas on paper. The oldest type of fuel cell is the alkaline fuel cell, also known as the bacon fuel cell, even though there's no bacon involved. It's named after its inventor, Francis Bacon, and though the bacon fuel cell was invented in the 30s, the technology has matured a lot. NASA is a major user of the bacon fuel cells, and you can find them in satellites and space shuttles that are still used today. They're relatively cheap to make, but they can't quite be used in smaller applications, nor could they really replace a national power grid. Other types of fuel cells have been used in cars by Toyota, Honda, and Hyundai, as well as in larger public transport vehicles like buses and trains. In the US, 113 facilities are being powered by hydrogen fuel cells, and their combined power output comes to 266 megawatts. All this shows that the idea works, and all we need to do is expand it to a more mainstream scale. So, why hydrogen? If we think about it, the biggest problem with fossil fuels is their waste, or the thing that gets left over that we can't use. For fossil fuels, it's the smoke with all the toxic stuff in it that's bad for the environment. Nuclear power is the type of clean energy that can best replicate the output of fossil fuels, but that technically produces waste too. Figuring out what to do with nuclear waste is the conundrum that keeps the world from fully embracing it. Renewable forms of energy don't produce harmful waste, but those are plagued by inefficiencies. Hydroelectric power depends on the kind of water flow you can achieve at the dams, while wind farms can only produce as much energy as the wind that blows them. Solar power is literally not available for like half the day. Locating renewable energy generators is a logistical challenge that the industry is grappling with, and so is coming up with the best way to store up the energy to use when the renewable source isn't available. Do either of these apply to hydrogen fuel cells? Well, let's see. Oxygen in most fuel cells comes from the air. We've got plenty of that. Now hydrogen, that's probably challenging to produce because it doesn't occur in nature. What does occur in nature is methane gas. There's too much of it. That's a big part of the whole problem. We can extract hydrogen from methane, and indeed, that's how around 95% of the hydrogen fuel is produced these days. So basically, this is a type of energy that can be produced at any time. What about the waste? The only waste products you get from hydrogen fuel cells are water and carbon dioxide, except waste is the wrong term for these because both of those are actually useful. It's kind of looking like it's all upside from here. Next, we have fuel cells in theory and practice. In all fairness, whenever you compare fossil fuels to anything in terms of pros and cons, that comparison never really works out for the dinosaur bones. There must be a reason we've hung on to them all this time. Let's put our nerdy glasses on and check out the data. Through science, each fuel is said to have a certain amount of energy contained within it. By comparing this internal energy with the amount of energy that we're able to extract from it, we can see how efficient a source of fuel is. When we apply the math to hydrogen fuel cells, the numbers we get are about 40 to 60% in ideal conditions. These aren't top marks by any means, but they're still improvements over what we have now. Did you know that the internal combustion engine of a car has an efficiency of 25%? That's right. This whole time, cars were only able to take advantage of a quarter of the fuel we were pouring into them. It's a wonder how they caught on. But these were just theoretical calculations. There's no such thing as an ideal situation in the real world. Can we compare fuel cells to fossil cells in a real context? Our best shot there is to compare the fuel cell cars we mentioned earlier to internal combustion engine cars. When fuel cells were compared to ICEs in the new European driving cycle, the fuel cell car that was tested scored 36%. That doesn't sound great until you compare it to a typical diesel car, which gets a whopping 22%. So those theoretical calculations do work out in practice too, and we need to ditch the ICE cars right now. So, where are all the hydrogen fuel cells? It sure looks like hydrogen fuel cells are better in every way than the fuels we use now. You might be wondering why there hasn't been a lot more investment in this technology compared to everything else. The reason reason, it turns out, is that while hydrogen is better than what we have right now, it isn't the best. Elon Musk famously derided the inefficiencies of fuel cells, calling them a dead end for cars. It's not every day that Musk fires off one of his hot takes and then turns out to be right, but he was in this case. Fuel cells can convert around 40% of their energy into output power for cars. Lithium-ion batteries? They can get up to 77% efficiency. We have to admit that they're kind of head and shoulders above fuel cells right now. In general, lithium-ion batteries have a lot of practical advantages over hydrogen fuel cells. The technology is a lot more mature, and they can charge up using the power grid we already have. In contrast, transitioning the world to fuel cells will require a whole new infrastructure for people to easily access hydrogen fuel, as well as teaching them how to make it work. The learning factor is a bigger factor than you might realize. We all know how batteries work, at least on the outside, if not the inside. On the other hand, videos like this one may be the first time many people hear about the concept of a hydrogen fuel cell. Our motivation for doing all this is based on the climate crisis we're facing and isn't going to wait for us to educate people on embracing a technology they don't understand. The fact is that for small-scale applications, it's simply faster to transition the world onto batteries, even if lithium-ion batteries have issues of their own. Now for some potential use cases for hydrogen fuel cells. Earlier, we compared hydrogen fuel cells to power stations and nuclear power plants, but so far we've been talking about cars and stuff. Can a fuel cell-based system actually generate power on a large scale for distribution to households? In other words, can you run a grid on hydrogen? Some countries are exploring that very possibility. In the US, many power plants are looking into using a mixture of hydrogen and natural gas to at least cut down carbon emissions, if not reducing them to zero. The Long Ridge Energy Generation Project is one of these. Producing 485 megawatts, they'll start with 95% natural gas and 5% hydrogen, and slowly scale up the hydrogen to 100%. In this arena, hydrogen has to compete with nuclear power, but the fight seems pretty stacked in favor of hydrogen right now. We already talked about how clean hydrogen is in terms of waste, but it's also politically clean. Finally, the future. We asked in the beginning if hydrogen could be the true future of energy. The answer we seem to have arrived at is that it's not the whole future, but it will be part of it. Hydrogen is really good at certain things and outclassed by other energy generation methods. But the good thing is that none of these are mutually exclusive. You can have lithium-ion in cars, solar panels in the desert, hydrogen in power plants, and most importantly, we can leave the dinosaur bones in the ground. That's the real goal, isn't it? We'll wrap up our deep dive into hydrogen fuel cells here. What do you think of hydrogen fuel? Does it have more potential than we think or less? Fire off in the comments below and make sure to like, share, and subscribe.